Hi everyone, I am Reem Abdel-Salam from CaresAI, and today I'll be sharing at work at the BioCreative chair task, Biomedical QA. So our presentation works as follows. We start with the background and problem overview, and then we go to the system overview and the results and some error analysis. So for the last years, we had like shared task and datasets available for medical QA. However, they are single hop where we have like a question and we generate a final answer with no explanation on how we got the answer. So we have like a single hop. We train like a large language model or a small language model to finally come to the conclusion. However, tackling a multi-hop is way harder because you have to go to the steps on how you got the answer in case of the biomedical field. So the problem, we have like a single hop datasets and a single hop competition, but this doesn't necessarily give us how the model, the reasoning on how we got to the answer due to the hardness of the problem and the non-availability of the dataset. So the shared task MedHopQA tackles this problem through using multi-step, is tackling this problem through two tasks. The first task is like having a single hop, and the second task is like having a multi-hop reasoning on how to evaluate the LLM for giving the answer. So the MedHopQA have like 1K biomedical question on diseases, genes, and chemicals with focus on rare disease. And the question requires reasoning like to come to the answer, to have like a better realistic scenario. So for the dataset, the provided dataset for the developing set have a 45 question instance annotated using short and long answer. For short answer is like one keyword, and for long answer is like the answer and how we got the reasoning behind it. For the test set, there is like a 10K question, and they serve as a benchmark for evaluating the large language models. So to tackle this problem, we have gathered dataset from different sources. We were able to gather around 10K QA pairs for biomedical questions. And this question varies from being a short answer, one single answer, or a long answer where we have like the answer and the explanation behind it. During training, we use the 10K gathered dataset, and we use the provided dataset as a validation for our models. For our methodology, we used supervised fine-tuning on the gathered dataset, and we used LLaMA 3.8b during training. We've conducted 3 experiments fine-tuning on a full dataset. By a full dataset, I mean we're training the model simultaneously to give the short and to give the long answer. And the second experiment is like training the model to give only the short answer, and the third experiment is to train the model to give only the long answer. So our pipeline would be like we have like a question and response, and we give it to the trained LLaMA, and it will give us a response in case of in short and long answer. However, we found in many cases that LLaMA 3.8b instruct doesn't follow the instruction and doesn't give a short answer. So we reprompt it again, like we ask it, giving the following question and an answer, extract only one phrase. And then we feed it to the trained model, and then it will be able to give us like the exact short answer in some cases. So our experimental setup for the hyperparameter configuration, we had like access to 2 NVIDIA RTX 380. And for the training time, it took like around 1 day. And for the inference, it took an average from 1 to 4 hours according to which experiment we are running. For prompting, we've used the following prompt. You're a specialized biomedical doctor trained to answer clinical and biomedical questions. Your task is to give a concise short answer that preserves the full name of the entity in question. For the results, the evaluation metric was the exact match and the concept level evaluation F1 score. So the exact match is like there is like a golden answer of one or two phrases, which is compared exactly the same wording to what the model should give. And for the concept level, it is more relaxed, where we don't need to have the same rewarding, but to have like an answer similar to the gold one. For results, evaluating the model, we have like results for the validation and test set. As you can see, for the supervised fine-tuning, the 3 experiments would have like a good result around 0.5 exact match in the validation, and for the concept level, we have like a high value around 0.8. However, at the test set, the model performance dropped to 0.2 exact match, and for the concept level, around 0.3. For this, we tried zero-shot Qwen instruct and zero-shot LLaMA 8B. However, we found those models to struggle with any knowledge about medical domain. They give an exact match around 0 at the validation set. For our error analysis, we've like investigated more where the problem lies. So one of the problem is that the LLaMA model doesn't give the exact format we want. Sometimes it would give the answer, or give like an approximation, or would give like a lot of information. Like we are asking what is the chromosome for some syndrome. It should give chromosome 2, but sometimes it would give chromosome 2 or just CHR2, or would give like the chromosome and the region. So this is why like the exact match would be low. Another thing we've noticed that there is like hallucination response. So a lot of time LLaMA 8B ignores the instruction which should generate one phrase and would give us like one phrase with a long explanation on how it got it. And for the zero-shot limitation, we found like that LLaMA and Qwen struggle to have any biomedical background. And as we said, for prompt following, LLaMA 8B struggled. However, it could have the right answer. So when we did like a more refinement to extract the exact match by doing pre-processing, the values increased from 0.2 to 0.49, which indicates that our training was successful. However, LLaMA 8B struggles with the extraction of the answer, but if we did like a better post-processing, we could increase the performance, which means that it was successful training and have like a biomedical information, good biomedical information. So as an example, we would give it like a question, and this should be the intended short answer. And as we see that LLaMA struggled to give us like the short answer. Sometimes it would give like a short answer and then continue about the information, or the information is like inside the paragraph we want. So our conclusion is that our work we've tackled the MedHopQA shared task using supervised fine-tuning of LLaMA 3 8B, and we augmented the data set to have like large knowledge around biomedical, and we explored strategies as fine-tuning, short answer, long answer, and both and zero-shot strategies. Our future work would include like having a better post-pre-processing to have like an exact match, and to work on prompt alignment between the model and the training. Thank you.